Greetings, I'm Thiruvikraman from Team AgroCentry and my teammate is Akhilesh. We are from PhD Institute of Technology and Applied Research, Coimbatore. We are currently pursuing BTech in Artificial Intelligence and Data Science. Today, one of the biggest challenges in agriculture is a lack of real-time soil nutrient monitoring. Farmers often face delays in detecting plant stress, diseases and soil salinity, especially in rural areas. These delays lead to poor crop yield, soil damage and long-term loss. There is a clear gap in localized and data-driven insights for farmers in rural regions. Without timely and accurate information, it becomes hard to manage soil health effectively. So, this is where AI and big data can make a major difference. By using soil sensors and other sensors combined with AI processing, we can provide instant feedback to farmers. This helps them to take quick actions. The chart shown here is a major concern. As the food production index increases, soil organic carbon levels are dropping. So, it is a clear sign that we need a smarter data-driven approaches to protect soil health for future generations to ensure sustainability. Our solution is built to support farmers with timely actionable insights. It begins with the data collection from multiple sources like NPK to measure nutrition level, soil moisture sensor for humidity and temperature, and satellite data to assess vegetation and salinity, and historical weather data. This data set is sent to Raspberry Pi based edge processing unit where machine learning models perform real-time analysis. We conduct NPK content analysis to identify nutrition deficiencies, risk prediction based on environmental factors, and salinity analysis combining both satellite and ground sensor inputs. This process data flows into analysis and recommendation layer, generating personalized fertilizer suggestion, early disease warning, and soil health report. All of this is delivered to the farmer via multilingual mobile web application equipped with AI-powered chatbot enabling easy interaction and continuous monitoring in multilingual and voice-based conditions. We use multiple AI models. First, we use CNN-based, that is convolution neural network-based AI model that analyzes soil image taken by the farmer. It can instantly tell whether the soil is healthy or nutrition deficient, giving you lab-like results. Second, for detecting soil salinity, we use AI and satellite image from Sentinel-2. It identifies salt-affected zones early and suggests zone-wise remedies before crops are damaged. Third, we apply machine learning model that uses live sensor data like NPK, moisture, temperature to predict upcoming plant stress given by the farmers to prevent loss. Finally, we use another ML model to check if your soil has the right amount of nitrogen, potassium, and phosphorus. It tells you exactly what is in need and what is in excess, saving both fertilizer and money. So let us move on to the demonstration of our project. So the first one is the Arduino UNO, which acts as a central unit that collects the data from each and every sensor and that processes the data and send to the cloud like ThinkSpeaks. And the next sensor is IR sensor. We actually use this sensor to protect the setup from the living beings such as dogs and cats around the farm. And moving further, this is the pH module. We have connected the pH module to the sensor, which will record the pH value of the soil simultaneously and send the data to the cloud, so that if any change occurs, then the user can identify. And this is actually an NPK sensor, which will measure nitrogen, potassium, and phosphorus amount in the soil. And this is the soil moisture sensor, which will measure moisture, pressure, and humidity in the soil. And additionally, we have implemented smart irrigation system using soil moisture sensor. So all these setup are connected in a series, and if in case of any irregularities, the lights will turn on in the sensor. The soil moisture sensor collects the data such as temperature, humidity, and pressure. This not only collects and processes the data, but also used for advanced analysis such as soil compaction index, time series moisture, humidity retention patterns, timely identification of stress conditions in plants, and also to predict the outbreak of crop-specific plant diseases. Additionally, we have used this data to make automated irrigation, that is crop-specific irrigation planner that is suitable for soil-specific environments. We utilize NPK sensor and pH sensor to collect the data such as pH, nitrogen, phosphorus and potassium levels in the soil. So it is very crucial for the operations such as soil fertility assessment and fertilizer optimization. So what we actually do is we extract all this data from the soil and we will have the default value of crop specific NPK and pH level. So using the AI algorithm, we will predict the residual NPK that is present in the soil and the lagging content that is available for the plant. So we recommend the farmer to refertilize or hydrate the farms so that the complete amount of NPK is absorbed by the plant. So this helps in sustainable fertilization process. So this data not only used for these things but also for the further analysis like time series nutrition changes in the soil and pH data. Data analysis. So we have taken the dataset that is available in Kaggle publicly. Our dataset consists of several soil parametric data and NPK level of soil with soil quality and crop yield. So let me move on to the important features instead of going to all these things. So the average humidity of each and every soil crop is around 78 and the temperature is around 22 degrees Celsius. So it is inferred from these graphs that rice plant needs more amount of nitrogen, where soya beans needs less amount of nitrogen. But when coming to phosphorus, again the rice leads and tomato decreases, like tomato needs less amount of phosphorus. Coming to the potassium part, the cotton and sugarcane needs more amount of potassium, while wheat needs less amount of potassium. So soil pH is generally 6.5 for every crops. Soil quality of rice is more, it requires more quality of soil to make high productions. So based on this graph, it is inferred that loamy soil has a high content in nitrogen and phosphorus as well as the potassium, but sandy soil is decreasing, or it is actually low for that. So overall it is proven that loamy soil has high content of nitrogen, potassium and phosphorus, while saline soil as well as the peaty soil has less NPK content. And these are the graphs that implements the total crop yield by the crop type and total crop yield by soil type. So in the correlation map, it is proven that NPK level and the soil pH level is highly correlated with the soil quality, with almost 99% till 100%. And also humidity and temperature play some of the crucial roles in soil quality. So on moving to the further analysis, we have done a deeper analysis for every parameters in the data set. So due to time constraint, we didn't tell that, but we will submit this analysis as a report for the hackathon. And as I said already, we are predicting the extra amount of nitrogen that is required, which is already present in the soil. So for example, I will input the value for nitrogen as 45 and phosphorus as 15 and potassium is 35 for the crop type called wheat. So from the machine learning model, it is inferred that additional amount of NPK required is 69, 38, 52. So basically we have used a random forest regression for this task. For soil salinity analysis, we incorporated a dataset called Sentinel-2, developed by European Space Agency. After pre-processing so many things, we displayed the India map for the Indian specific region, where the pink color patches in the map represents the low soil content, saline content, and white color represents the high saline content. Not only we have done analysis part, but also we have implemented the whole integrated application system where the farmer can use the website for multiple access and some of the informations. Competitive advantage. Unlike existing systems that rely on pre-trained models using soil data from other regions, our system is trained on localized data and satellite data, ensuring highly accurate and region-specific analysis. This means our prediction, whether it is NPK need, salinity levels, or the other data, are just not theoretical but truly reflective of our soil, our climate, and our crops. That is what makes our system far more effective and better in real world. And coming to the uniqueness, it is noteworthy to mention that unlike existing systems using foreign dataset, our system is trained on the real soil and satellite data directly from the farmer's region, making results far more accurate and reliable. And using multiple AI models working together to predict nutrition needs, detecting salinity, and automatically activate water mechanisms when needed. It works without internet by just Bluetooth for the process automation, supports multilingual languages, and gives voice alert, making it easy for the farmer to use. Using satellite image and entering the location, our system provides instant salinity analysis, but no lab or export needed. Challenges. New technology can be expensive and slow, so we focus on using local data and affordable sensors to keep costs low. Since rural areas have often poor internet and tough weather, our system works offline through Bluetooth communication and uses weatherproof devices to keep running. Farms vary in a lot of size, and many workers are not technological expert, so we made our app super easy to use and sensors flexible for any farm, either big or small. Equipment safety is concerned, switching from old to new methods takes time, so we choose storage gear that hard to damage or steal or built-in smart calibration to make switching simple. So overcoming these challenges has made our project both robust and farmer-friendly. Cost estimation. Currently, the farmer is spending more than 16,000 per acre on excess fertilizers, manual soil testing, labor and consultation. Traditional methods often leads to inefficient resource use and higher costs. By integrating advanced sensors and AI applications, our system reduces these expenses to approximately 8,000 rupees per acre, representing a remarkable milestone of more than 50% of cost reduction, so making farming more easy and efficient and sustainable. ROI. Our solution needs one-time investment of Rs 20,000 per hectare with a break-even point reached in under 4 months. By implementing AI technology and sensor, it enables farmers to save more than 60,000 rupees annually through precise fertilizer and reduced labor costs. Over 5 years, this will result in a net return of 3 lakh rupees per hectare. Beyond these benefits, the system fosters healthier soil and reduces chemical usage. As a result, we would like to conclude that ensuring sustainable soil health is not just an agricultural goal, but it is a foundation for a healthier planet and the healthier people. Healthy soil leads to stronger crops, better nutrition, and greater food security. So, by protecting and restoring our soil through smarter technologies and deeper analysis, we are not only improving farm productivity, but also securing a sustainable future for generations to come, where both the land and its people can thrive. Thank you.